students, and welcome back. After a long time, we are uploading the video on students' demand, and that is the numericals based on refraction of light at plane surfaces part A. As usual, we must begin with the list of all formulae, right? Let's start. Refractive index is the first concept which we have to see. And the first formula of refractive index is based on Snell's law when light is travelling from one medium to the other medium. In this figure, we can very well see light is travelling from medium 1, that is air, to medium 2, that is glass. Let us understand this figure. Here is angle I. What is angle I? Angle made by incident ray with the normal. And this is angle R. Angle R is angle of refraction made by refracted ray with the normal. So first I must know which is angle I and which is angle R. Once I know this, I can very well find out refractive index of this medium glass with respect to air. How? See the formula, sin I upon sin R. How do I read this? 1 mu 2, is it right? No, absolutely wrong. What is this sign mu? It is called as mu. But how do we read it? We read it as refractive index of second medium with respect to the first medium. Never ever read 1 mu 2. It is refractive index. Mu को क्या कहेंगे? Refractive index of second medium with respect to first medium. And children, please understand refractive index for a given pair of media. देखिए रिफ्रैक्टिव इंडेक्स हम जब निकालते हैं तब लाइट एक मीडियम से दूसरे मीडियम में जा रहा है. सो रिफ्रैक्टिव इंडेक्स इज ऑलवेज फॉर अ पेयर ऑफ मीडिया, राइट? हियर इट इज एयर एंड ग्लास is always constant. Whoever may find it, refractive index of a given pair of media always remains constant. Please keep this in mind. Fine. Now, this refractive index can also be found by other formula. Let us see what's that formula. Mu, now you know what is mu, refractive index. Mu equal to speed of light in vacuum upon speed of light in medium. Now, what do you mean by that? Just now I told you children, refractive index is always found for a pair of media. Like light is travelling from one medium to the other. But whenever they don't give from which medium light is travelling, it is always understood that light is travelling from vacuum to that other medium. And you all have studied in your theory part. When light travels from one medium to the other, it changes its speed. उसका speed बदलता है. जैसे हवा से ग्लास में लाइट जब अंदर जाएगा, what will happen to its speed? Its speed will obviously decrease, yes or no? So whenever light is traveling from one medium to the other, obviously speed is going to change. Hence, refractive index can be found by one more formula, speed of light in vacuum, if light is coming from vacuum, and speed of light in medium, उसका हमें क्या लेना है? रेशो लेना है. If they are saying light is traveling from air to glass, speed of light in vacuum? No, it will be in air upon speed of light in that medium, that is glass. So this is the second formula by which one can find out refractive index. One more formula is there. Let us see that. Lambda dash equal to lambda upon mu. I hope you all must have studied what is lambda. Lambda is nothing but wavelength of light. And my dear kids, whenever light is traveling from one medium to the other, its wavelength changes. Speed also changes. Wavelength also changes, and in theory you must have studied frequency never changes because frequency depends upon source of light. This is your theory part. So when light is traveling from one medium to the other, I said wavelength changes. Suppose if I consider wavelength of light in first medium is lambda, and when it changes it becomes lambda dash. पहले मीडियम में वेवलेंथ क्या है? लैम्बडा. जब लाइट दूसरे मीडियम में जाता है उसकी वेवलेंथ क्या हो रही है? लैम्बडा डैश. सो हियर इज द रिलेशन फ्रॉम योर टेक्स्ट बुक. Lambda dash equal to lambda upon mu. Of course, you can take this mu over here and you can certainly write lambda upon lambda dash. So, we are getting these three formulae to find out refractive index. Yes, sin I upon sin R, speed of light in first medium upon speed of light in second medium, then lambda dash equal to lambda upon mu. Isn't it easy? It's very easy, but one must know all three formulae. So that what happens? You just check the given. If in my given, in the numerical, if wavelengths are given, I should not think of all this. I should think about this formula. If speeds are given, I should think about this formula. And if angle I and angle are given, and its sine value is also given, I must think about this formula. Very simple. Okay, let us move ahead. Principle of reversibility of light. Okay, what do you mean by that? Let us understand. Can you see, children, here light is traveling from first medium to the second, right? If light is traveling from first medium to the second, what would be the formula for mu? Mu, that is refractive index of water with respect to air. Second medium is water, first medium is air. We all know it is sin I upon sin R. We already have done. But imagine if light is starting from water and then entering air. Do you know, children, in that case, light is going to follow the same path, but the direction would be opposite. When it was traveling from air to water, this is the path. This is C, B and B, A. But if imagine here is the source of light at A. Imagine at A there is source of light. What would happen? Light will start like this AB and BC. That means this angle R will become angle I and this angle I will become angle R. Principle of reversibility. What do you mean by that? हम गाड़ी रिवर्स कैसे करते? रास्ता वो ही है लेकिन हम अपोजिट दिशा में गाड़ी को पीछे लेके जाते हैं, राइट? सिमिलरली हियर इफ यू जस्ट चेंज द पोजीशन ऑफ द सोर्स ऑफ लाइट, light will follow the same path but in the opposite direction. So if in my first formula I am talking about refractive index of second medium, that is water, with respect to air, I take the formula sin I upon sin R. मुझे अभी उल्टा करना हो तो, if light is starting from air and light is starting from water and entering air, then I would say refractive index of this medium now. This becomes second medium, right? That is air. Refractive index of air with respect to water. Then what would be the formula? This angle R, I told you, is going to become your angle I, right? So sin R upon sin I. Just see both the formulae. What do you observe? If I have refractive index of water with respect to air, I have sin I upon sin R, and if I do it little bit ulta, mu उधर का उधर, but refractive index of air with respect to water, ये formula देखो, ये उल्टा हो गया. But in mathematical language, ये उल्टा हो गया को क्या बोलते हैं हम? This is the reciprocal of the first. Yes or no? So can I write then refractive index of water with respect to air will be equal to 1 upon, that is a reciprocal of refractive index of air with respect to water. Please remember this. At times, they will give you value of this refractive index of water with respect to air, and they will ask you what is the refractive index of air with respect to water. कुछ नहीं करना है, सिर्फ उसका reciprocal लेना है. Suppose if they give you this value as 2/3 and they are asking you to find out refractive index of air with respect to water, just take the reciprocal. 2/3 का हो जाएगा 3/2. I think everything is easy. Please remember all these formulae for your part A, right? Now, let us see one more formula of refractive index. Refractive index चल ही रहा है, खत्म ही नहीं हो रहा है ना. Part A is completely based on refractive index, right? Please see this picture. It is from your textbook itself. Suppose consider that this is a water body, like it might be a pond, it can be a swimming pool, and you are standing out, that is you are in air, and you are observing something at the bottom of this swimming pool. See, O is the object at the bottom of the swimming pool. O can be any tile at the bottom of the swimming pool, right? Now, you are observing, you are an observer who is in air. आप क्या देख रहे हो? आप स्विमिंग पूल के बॉटम में जो एक टाइल लगी है उसको देख रहे हो. So object is that tile. Now children, tell me, how will light travel? Is it going to travel from your eye to the tile? No. Light always starts from the object which you see. So light will start from this O, it will first pass through water and then it will enter air. That means light is traveling from denser medium to rarer. Light ray is going to bend away from the normal. We all have studied in the theory. So this is the path of light when you are watching something present inside water, right? Now, what happens? You have studied in the theory. The bottom of the swimming pool or the tile appears to be raised because we know it is a virtual image of the object. तो आपको ये जो object O है वो कहाँ दिख रहा है? At eye. That is, the object appears to be raised. So, what is the real depth of swimming pool? This much is the real depth. At the bottom object O is there. But for you now, the tile appears to be raised, the bottom appears to be raised. For you now, apparent depth is this much. AI is your apparent depth. AO is the real depth. In such cases, we have one more formula of refractive index, and that is refractive index. किसकी refractive index? Water की refractive index. Refractive index is equal to real depth upon apparent depth. Please remember this formula whenever such problem will come. Whenever they give that somebody is watching some object which is placed in denser medium, object appears to be raised, that time the formula is refractive index is equal to real depth upon apparent depth. Apparent depth means virtual depth. आपको जो feeling हो रहा है वो वाली depth is apparent depth. Fine, easy children. So please revise this formula, write 2 to 3 times, and then you all can start with the numericals for part A. Okay, let us move ahead. Let us see the numerical now. See the first numerical. The speed of light in air is 3 into 10 raised to 8 meter per second. Calculate the speed of light in glass, and refractive index of glass is given to us as 1.5. Children, I already have told you, among those 3 to 4, formulae of refractive index, which formula to be used here? If this problem talks about speed of light in one medium, speed of light in second medium, of course, we have to use the formula refractive index of second medium with respect to first medium is equal to what? Guess it, guess it, guess it. Speed of light in first medium upon speed of light in second medium. Let us see what is given to us. The speed of light is given, refractive index of glass is given, and to find speed of light in glass. First medium is air and second medium is glass. Formula to be used, just now we spoke about it, speed of light in air upon speed of light in glass. Okay, so by using this formula and by substituting the values, you can just substitute refractive index as 1.5, speed of light in air as 3 into 10 raised to 8 meter per second upon speed of light in glass. You can certainly take this denominator over here and 1.5 can go into the denominator. So this is what we get. What is 1.5? What is 1.5? 1.5 is half of 3, nothing but 3 by 2. See, those who can do it orally, 1.5 ones are, 2s are 3. Those who cannot, you can write this 3 by 2, and then afterwards, what will happen to this 3 by 2? It will become multiplied by 2 by 3. Dividing by a number is nothing but multiplying by its reciprocal. We all know that. And finally, we get the answer 2 into 10 raised to 8 meter per second. What is that? It is speed of light in glass. This is such a simple numerical, can be asked in your board. So please prepare your all formulae thoroughly. That is the key to solve all numericals. Let us move ahead. The speed of light in diamond, oh my God, such a big number, 125,000 kilometers per second. Children, always pay attention to the units. Now, this is not just meter per second, okay? Let us see. What is refractive index? Where speed of light in air is 3 into 10 raised to 8 meter per second. My dear kids, here they are asking about refractive index of diamond. That means light is traveling from air to diamond. Okay, again this problem talks about speed of light. So obviously your formula would be speed of light in the first medium upon speed of light in the second medium. First medium is your air, second medium is diamond. Let us see what is given to us. Speed of light in diamond is given to us. Speed of light in air is given to us. That is 3 into 10 raised to 8 meter per second, right? Here I have converted 3 into 10 raised to 8 meter per second into kilometers as 3 into 10 raised to 5 kilometers per second. Children, if you do not know why I did this, please try to understand meter and kilometer relation. 1 kilometer equal to 1000 meter or 1 kilometer equal to 10 raised to 3 meters. But if I have to go from meter to kilometer, I will have to divide by 1000. If I divide by 1000, nothing but it is upon 10 raised to 3, right? I am dividing by 1000. So 3 into 10 raised to 8 upon 1000 means upon 10 raised to 3. But this 10 raised to 3, when it goes up, then it will become 8 minus 3 as per law of indices. And finally we get 3 into 10 raised to 5 kilometer per second. Please remember this value, 3 into 10 raised to 8 meter per second and 3 into 10 raised to 5 kilometers per second. Once both the units are same, I can very well divide it. Then our formula, refractive index of diamond we have to find out. Therefore, it is the ratio of speed of light in air, that's the first medium, upon speed of light in the second medium, that is diamond. And finally, we will substitute, and of course, you need to do this calculation. Here 3 into 10 raised to 5 are written as 3 के ऊपर 5 0 दिए हमने upon 125,000. We can understand these 3 zeros and these 3 zeros will go, and finally what remains is 300 upon 125, which you can certainly divide by 5, and it is finally simplified to 2.4. Thus, refractive index of diamond is 2.4. I hope the problem is easy based on the same formula again. Let us move ahead. The refractive index of water with respect to air is 4 upon 3. Refractive index of water. Second medium is water. Light कहाँ से कहाँ जा रहा है? Light is passing from air to water. Is 4 upon 3. What is the refractive index of air with respect to water? अभी उल्टा पूछा है. Try to recollect the theory. Principle of reversibility. Right? Okay. Whenever you get such numerical, it is just taking reciprocal, which I have already told you. Let us see now, given refractive index of water with respect to air. How have we written? You see children, refractive index of water with respect to air is 4 by 3. And what is asked? Find out refractive index of air with respect to water. Mu, refractive index of air with respect to water. Ulta pulta hai. Ulta pulta matlab what you have to do? You have to take the reciprocal. Our formula is refractive index of water with respect to air is equal to 1 upon refractive index of air with respect to water. Simply substitute the values, you get the answer. This is given to you as 4 by 3 equal to 1 upon refractive index of air with respect to water. What would you do then? This 4 by 3 can be taken here with refractive index of air with respect to water can be taken over here. So it is 1 upon 4 by 3. Reciprocal of 4 by 3 is of course 3 by 4, and that 3 by 4 can be simplified as 0.75. 4 से 3 को डिवाइड करना है. प्लीज कीप इट इन माइंड. 4 से 3 को आपको डिवाइड करना है. यू गेट द आंसर 0.75. Thus refractive index of air with respect to water is 0.75. देखिए हमने जो जो फॉर्मूले किए वो ही हम यूज कर रहे हैं. सो फॉर्मूले thoroughly prepare करो. Okay, let's move ahead. A ray of light of wavelength 5400 degree angstrom suffers refraction from air to glass. देखिए लाइट कहाँ से कहाँ जा रहा है? From air to glass. Its wavelength was this much, and they are also saying take refractive index of glass with respect to air as 3 by 2. Find the wavelength of light in glass. I already have told you whenever light is passing from one medium to the other, its wavelength changes. And whenever wavelength is changing, and when the problem is talking about wavelengths and refractive index, what is the relation between them? Try to recollect the formula. Lambda dash equal to lambda upon mu, or it can be mu equal to lambda upon lambda dash, right? Again, I am telling you the importance of by hearting the formulae. Let us see what is given to us. Wavelength of light is given to us. Refractive index of glass with respect to air is given to us as 3 by 2. And they are asking us to find out wavelength of light in glass or in the second medium. Which formula to be used? Already discussed. Lambda dash equal to lambda upon mu. Let us substitute the values now. Lambda dash is nothing but lambda in glass. Second medium is dash, that is glass, and lambda would be lambda in air, that is wavelength of light in air, wavelength of light in glass upon refractive index of glass with respect to air. Let us substitute the values. Lambda in air, that is wavelength of light in air, is substituted 5400, and refractive index is substituted as 3 by 2. We know this 3 by 2 can be multiplied, but it would be 2 by 3. Dividing by a number is nothing but multiplying by its reciprocal. So you can certainly divide it as 3 ones are, and you can write here 1800. Thus the answer comes 1800 into 2, 3600 degree angstrom. Thus, wavelength of light in glass is 3600 degree angstrom. Very simple, right?